In this demonstration, I'm going to show you the data that you need in order to calculate the temperature change in a piece of metal that is stored in some dry ice to find out how cold is the dry ice. So it's a similar problem to one that we've done before, but instead of looking at the temperature of a very hot flame, we're looking at the temperature of very cold solid carbon dioxide. That's what dry ice is. It's not really ice, which is made of water. It's carbon dioxide gas, which is compressed and cooled to make it into a solid form. It's so cold that if you were to hold it in your hand, you could instantly get frostbite, which would be very painful. So I'm going to take a very cold piece of aluminum and I'm going to put it into a calorimeter that contains a mass of antifreeze solution. Antifreeze is the chemical ethylene glycol. It won't freeze, so that will avoid some other changes that we wouldn't be able to account for in our experiment. So as I go through and do the demonstration, you'll want to record on your data diagram any information needed in order to solve the problem. I'm not going to tell you what data goes where. Your job is to watch closely and record the necessary data. So I'm going to begin with my calorimeter cup. I'm going to put it on the balance and weigh it first while it's empty. And then I'm going to add some warm ethylene glycol. Then I'm going to take this and put it over in my stand and measure the temperature of the warm ethylene glycol. One thing I need to know about the ethylene glycol is what is its specific heat capacity. Next, I'm going to take the piece of aluminum and I'm going to put it into the calorimeter with the ethylene glycol. Here are the specific heat capacity and the mass of the piece of aluminum. The piece of aluminum is ready to go into the dry ice now. So I'll open up the calorimeter, put in the very cold piece of metal. I'll put the top back on. The cold piece of metal and the warm ethylene glycol are exchanging heat inside the calorimeter, and as that process occurs, the temperature of the piece of metal is increasing. It's warming up, and the temperature of the ethylene glycol is decreasing. It's cooling down until they both arrive at the same ending temperature, which you can see right here. Using the data that you've collected now, you can fill in the data diagram. You can use that data to calculate the temperature change in the piece of metal and use that to calculate what was the starting temperature of the metal when it was in the cold, dry ice bucket.